All right, we're going to try doing a couple of problems that the book does in a funny way that I'd prefer that you not use their method. So I'm showing you exactly how I would like to do that, and we're going to start with page 438, homework problems from Monday night. That's Monday the 22nd, and we were doing number 48. This is the third to the last question in last night's homework assignment. So what we want to do is always start out with the given. And with the given on this particular problem, we had STP. Now, because we're told STP, that means we know two things, right? We know our temperature, which is equal to 273 Kelvin, and we know our pressure, which is equal to 1 atmosphere. So now that we know those two things, let's see what else we know. The find, on the find, we are told that we're supposed to find the density of this gas. And that is always going to be in grams per some unit of measure that represents volume. And because we're working with gas laws, our volume is usually going to be in liters. So I'm going to make this grams per liter. Now, there's something special that happens with STP, and the reason I'm going down the ladder here and I'm going to use all the PV and RT stuff is because that helps everything relate to everything else. STP has set us at 1 atmosphere and 273 degrees Kelvin. However, we also know something else that I want to put as a little side note here for you, that at STP, the 1 mole of a gas is always equal to 22.4 liters. Now look what that does. It gives us temperature, pressure, moles, and liters, all related to each other. That's important because you can't just say, oh, I have 22.4 liters. Well, what does that relate to? In this case, it relates to not only moles, but it also relates to temperature and pressure. This is a definition of the conditions of STP relating moles to liters. So, what I'm going to do in my little list of things, this was not given, but I know this because I was given STP. I know that if I set this to 1 mole, that then my volume is going to wind up being 22.4 liters. Now, I'm looking for grams per liter. How am I going to get grams per liter? Well, there's one other thing we were given. We were told that the molar mass of this particular gas is 44 grams equals 1 mole. Now, if I have 24 grams equal to 1 mole, that means that I can change this into grams. And look, I already have liters. I know what liters is, so I've got the liters for my density. And I have the number of grams that correspond to it if I change this moles into grams, which means all I have to do is make a little grid here. I've got moles over 1 times 44, whoops, I'm upside down, times 1 mole on the bottom. Oh, I was right side up. I've got 1 mole on the bottom. I was right the first time. And I've got 22.4 liters on the top. Oh. Man, I'm brain dead. Here we go. I'm using this guy, not the 22.4 liters. We're trying to get to grams. So we have 44 grams. I was right the first time. And on the bottom we have 1 mole. And now when we multiply that out, we have 44. Can we see that? Oh, of course, it's not on. It would help if it were on. We have 44 grams times our divided by. No, we got 44 grams. So this is going to be 44 grams. And we have successfully converted our moles into grams. Now I just simply take grams, 44 grams, over 1 mole. And I know that that is or over 22.4 liters. 22.4 liters. We're taking our volume and we're taking our grams. So 44 grams over 22.4 liters. And now all I have to do is divide those guys out. We got 44 divided by, does that show up okay? It does, good. At 22.4 liters. And I get 1.96. If you use the method in the book, you'll come up with the same number. But I'm trying to get you to relate the PV/nRT and the density, and to do a little problem solving in your mind when you get to problems like this. This is grams of our gas, and that is the answer for that guy. Now, I think we can go ahead and put our second problem on here as well. And the second problem is a little bit different. Now we're going to go to problem number 49. And in this one, we are given the density. Let's move this up a little bit. That'll be a little bit easier for the lighting. And our density was given to us as 1.09 grams per liter. Now, always put in your units of measure, especially in this gas loss stuff. You will get totally lost if you don't have those units of measure in there. So, pressure in this problem is equal to 1.02 atmospheres, and you can see that in the book. Our temperature is equal to 25 degrees centigrade, and whenever we see temperature in centigrade, we always want to get it straight into Kelvin. So we add our 273, and that gives us 298 Kelvin. Now, in this particular problem, I want to set my N equal to 1. Why? Because I want to have 1 mole, which for our find, which I didn't write down yet, let's get that in here, we're supposed to find the molar mass. And that is grams per mole. Notice I need to have these measures here. If I don't know what those are, I'm totally lost in my problem. So, PV/nRT is going to let me find a volume because we are looking for the volume to give us liters, and we can take our density, once we know the number of liters, multiply by density, and that gives us our grams. That equals 1 mole. So let's do the volume, or find the volume using PV/nRT. We have 1.02 atmospheres times 24.0 liters. And this was atmospheres over liters. I should have put a times here between these guys. And this is over 1. And now when I multiply these guys out, I'm going to have 1.02 times 24.0, which we don't need to put the 0.0 in for the calculator's sake. And we come up with 24.5, and what do we have left here? Oh man, what have I done? Okay, let's cool it.